Hello, and welcome back to Calero Academy. We left off previously by saying that we would prove the second part of that the correlation coefficient is between -1 and 1 by just proving it from basic first principles. So, fulfilling that promise, we're going to start off with the definition of the covariance. Covariance of x and y is simply the expectation of x minus the mean of x all times y times the mean of y. So, there's a very interesting theorem called the Cauchy-Schwarz theorem. Cauchy-Schwarz. It's very important. It says that the sum from I is equal to 1 to some n of x at xi and yi, the absolute value of that all squared, is less than or equal to the individual sums times each other. So basically, the sum from j is equal to 1 to some n of xj squared times the sum from some k is equal to 1 to some n of y sub k squared. Since the expectation is simply a type of sum, we can just write the covariance of x and y, the absolute value of that all squared, is going to be less than or equal to the individual sum product, so the product of the sums. So we can write the expectation of x minus the mean of x squared times the expectation of y minus the mean of y, all squared. Now, these are simply the variances as we learned before, so we can write the covariance of x and y, the absolute value of that all squared, is less than or equal to the variance of x times the variance of y. Let's take the square root of both sides, and we don't have to worry about the right-hand side since the right-hand side is always positive. So, we can write the covariance, the absolute value of the covariance of x and y is less than or equal to the standard deviation of x times the standard deviation of y. Dividing both sides by the standard deviations, we have the covariance of x and y divided by the standard deviations of x times the standard deviation of y is less than or equal to 1. And since the left-hand side is equal to the correlation coefficient, rho is equal to that, we can write that the absolute value of the correlation coefficient is less than or equal to 1. Or that the correlation coefficient is between -1 and 1. And that completes the proof. Thank you for watching. This has been a Calero Academy production. Thank you and goodbye.